Today we will discuss about the solar energy and different type of collectors used for collecting solar energy so as to perform some type of useful task. Okay, so a brief introduction to solar energy. So this is the radiant light and heat from the sun that is harnessed using a range of evolving technologies such as solar heating, photovoltaics, solar thermal energy. So means we can utilize heat and light from the sun and do some type of useful work. So solar energy, that is the largest source of energy received on earth. Okay, but its intensity on the earth's surface is quite low, means it is diffused, scattered. So solar energy, it is rapidly becoming the ultimate energy source because of its non-polluting character and its inexhaustible supply. Yes, because energy obtained from fossil fuels, okay, that they may exhaust, and they are useful unless their stocks are available. And when their stocks are exhausted, we won't be having these fossil fuels. So we have to search for an alternate energy as well. Now, sun is the ultimate source of most of our renewable energy supplies. So most because directly or indirectly, we are getting energy from the sun, like wind energy. That is also an indirect form of solar energy. Biomass, that is also indirectly getting from the sun. Geothermal, we are indirectly getting from the sun. So directly and indirectly, we are getting a lot of renewable energy sources from the sun. So in the sun, there is an enormous nuclear fusion reaction which converts hydrogen into helium at the rate of 4 million tons per second. Okay, so the source of energy, that is the nuclear fusion reaction. Now, sun radiates energy by virtue of high surface temperature. So how much temperature? It is approximately 5,772 Kelvin. Now coming to the point when I said that the energy that is diffused, it is scattered. Now so as to utilize it, we have to collect it, concentrate it at some point. So solar energy collector, that is a device which absorbs the incoming solar radiation, then converts it into heat and transfers this heat into a fluid or maybe any other medium. So medium could be air, water, oil that is flowing through the collector. Through on the collector, the sunlight that is falling, so that is, and that is getting the heat, and through this medium or fluid, that heat is collected and transferred to some other medium for some type of task which is to be performed, or we have to store the heat. So there it will be transferred by that fluid. Okay, so the solar energy thus collected is carried from the circulating fluid either directly to the hot water or space conditioning equipment or to thermal energy storage tanks. So some of the applications here we can see. Space conditioning is there, thermal energy storage. Even we can do that. And storage tank from which it can be drawn for use at night or cloudy days, means it is a storage. So when there solar availability is not there, in that time we can take this energy from the storage. So solar collectors, they are classified as low, medium or high temperature collectors. So name indicates low temperature, high temperature and medium temperature. Okay, so low temperature collectors, they are used for smaller non-intensive requirements common in the household. So usually less than 150 degrees Celsius temperature. After that, medium temperature collectors are used for heating water or air for industrial and commercial use. So the range is 150 to 400 degrees Celsius. Then high temperature collectors concentrate sunlight using mirrors or lenses. Yes, now we need these things, mirrors or lenses, so as to concentrate the sunlight at some particular area or some particular point. So they can, the temperature can go up to 400 degrees Celsius. More than 400, sorry. Till 400, that is medium. 150 to 400, and more than 400, that is high temperature. So now the manufacturing or the designing of the solar collectors, it is of two types: non-concentrating collectors and concentrating collectors. Now discussing the non-concentrating collectors. So in this type of collectors, the collector area is the same as the absorber area. It means the area usually that is more for a collector. The collector area that is usually more, normally the same as the absorber area. We will discuss this one by one, then we will go in detail. The whole solar panel absorbs light. Yes, the whole of the panel that will be absorbing the light because that is the same collector in the absorber, so area is more. Non-concentrating solar collectors are generally used for low and medium temperature. Now, in contrast with these concentrating collectors, they are having a larger interceptor than absorber, meaning absorber area that is less. Okay, then the interceptor, because here we are also using the lens or the mirrors. So they are concentrating the light at some area where the absorber is. And then concentrating collectors are used for high temperature requirements because they will collect the sunlight and collect the heat at some particular area. So their temperature will be very high. So here is the briefing: solar collectors, concentrating and non-concentrating. In concentrating, further imaging, non-imaging, further in imaging, point focus, line focus. Then in non-imaging, there are compound parabolic collectors. And under point focus, there is dish system with dual axis tracking. In line focusing, there is parabolic trough, linear Fresnel with single axis tracking. And on the other side, non-concentrating type, they are flat plate collectors and evacuated tube collectors. Now let us discuss this type of collectors. So non-concentrating solar thermal collectors are generally used for low and medium energy requirements. Okay, we have discussed that. Solar water heating is the perfect example of non-concentrating. Yes, water heating using solar energy. That is an example of non-concentrating type of solar collector. So common collectors used for solar water heaters are flat plate collectors and evacuated tube collectors. So now discussing flat plate collector. So it consists of, let me show you a diagram first, then I will again come back to this. Okay, so here on the top, solar radiation is coming. Okay, there is transparent screen, then black absorber plate, below that fluid tube, then below that thermal insulation. So the surface that is flat, so that indicates the name why it is given called as flat plate collectors. Okay, so metallic flat plate absorber, okay, tube or channels for the fluid, then transparent toughened glass sheet, protection as well. Okay, also one more thing the glass offers, that is greenhouse effect, collection of heat. Okay, then fiberglass insulation. Okay, so that the heat should not leak to the environment. Coming back to the construction working point. So they consist of thin metal box with insulated sides and back, a glass of plastic cover, a dark color absorber. The glazing allows most of the solar energy into the box, thus preventing the escape of much of the heat gained. Yes, that should also be our priority because heat we are collecting. But what if we cannot store it? It will be leaked back to the environment. So our collector will not be much useful in that case. So the absorber plate in the box painted with a selective dark color coating is designed to maximize the amount of solar energy absorbed as heat. So running through the absorber plate are many fine tubes through which water is pumped. Okay, as the water travels through these tubes, it absorbs the heat. This heated water is then gathered in a large collector pipe to be transported into the hot water system. Okay, so in this way, this collector that is working. Solar radiation from the top. Now they are coming from transparent screen to black absorber plate. Now it is absorbing the heat. From there, these tubes In the tube, the water is flowing and it is carrying away the heat and it is stored there. Next one is the evacuated tube collector. So evacuated tube collectors are more modern and more efficient in design. Let me show the diagram how it looks like. So protective cover is there, copper rod is there, then working fluid is there, absorber, vacuum space. Mostly similar components as compared with a flat plate collector. Okay, evacuated tube system. This heat loss is reduced by almost totally eliminating conduction and convection heat loss. Okay, so these can heat water to much higher temperatures and require less area. However, they are also correspondingly more expensive. So instead of an absorber plate, water is pumped through absorber tube. So that are metal tubes with a selective solar radiation absorbing coating. So the tube, they are coated with this radiation absorbing material, chemical. Okay, so gaining heat before going into the collector pipe. So there also they're gaining the heat, then goes to the collector pipe. Now coming to concentrating collector. A concentrating collector, that is a device to collect solar energy with high intensity of solar radiation on the energy absorbing surface. So what is the difference between this concentrating collector and the previous flat plate or evacuated tube type collector? So let us see it in the diagram. So here we can see. So there is a reflector, that is basically the concentrator. So light is coming, striking the reflector and reflecting back, and they are converging to one very small area. So that is the absorber. Okay, so it is coated with the insulation with outer surface, that is coated with the insulation so that the heat that is not leak to the environment. Okay, through convection, through conduction, the heat should not be leak out. So it is concentrating most of the solar light or radiation to the surface area shown there in the small circular area. Now it is further oriented as per the direction of the sun. So that's why there is a orientating system there. Okay, concentrating collector is a special form of flat plate collector modified by introducing a reflecting surface between the solar radiation and the absorber. So that was a curved type, concave type reflecting surface. So here the receiving area of solar radiation is several times greater than the absorber area and efficiency is very high. Okay, just we have seen there. The receiving area that was very large. It was concave mirror type area. Okay, so mirrors, lenses, they are used to concentrate the sun rays on the absorber. Absorber was having a smaller area, whereas the receiver, the collector, that was having a larger area. So the temperature of the working fluid can be raised up to 500 degrees Celsius. For better performance, the collector is mounted on a tracking equipment to always face the sun. Okay, because wherever the sun is moving, if it is on the some direction is changed from east to west, okay, then the amount of radiation falling on the reflector that will be reduced. Correspondingly, the temperature will be reduced in the absorber. So as to maximize it, the tracking system is there. So it is orienting. Okay, types of concentrating collectors. The point focus technology. So one is Fresnel reflector based dish. Then another type, dual axis track paraboloid dish. Then in line focus technology, there are parabolic trough collector and linear Fresnel reflector. On non-focusing technology, there is compound parabolic collector. So all of them, they are concentrating collectors. Now, next we will discuss them. Fresnel reflector based dish. Okay, or in the short, ARUN dish is made from panels of flat mirrors mounted on a frame such that the incident light is reflected to a cavity receiver, which is specially designed to reduce heat losses. Now let's see in the diagram. Sunlight is falling, then there's a reflector, Fresnel reflector based dish is there. So light is falling there. And from there, they are concentrating to very small area where there is the receiver. From there, the water or the fluid that is flowing, it is getting heat. The red colored line that is showing with high temperature coming to the storage tank. The heat is transferred to the storage tank. Then again, the fluid or the water that is circulated and it again comes to the receiver. So Fresnel reflector surface, they are the small mirror type in the parabolic or the concave type dish. That is the arrangement of Fresnel reflector based dish. Okay, from the storage tank, the steam or the hot water or hot thermal fluid that is taken and it is utilized for some type of task. Usually Fresnel dishes are large and could have an aperture area of 100 meters meter. Then the reflector and the receiver mounted on top are moved to track the sun such that the reflector faces the sun at all times throughout the year. This is to maximize the efficiency. Maximum heat can be taken. Then Fresnel dishes have high efficiency throughout the year. Yeah, that's why, because it is tracking the sun. Now coming to the next part, that is paraboloid dish collector. So the paraboloid dish consists of mirrors mounted on a truss structure such that the incident light is reflected to a cavity receiver, which is specially designed to reduce convective and radiation heat loss. Okay. Here, what is the main difference? The paraboloid dish is there. Here also the falling rays, the radiation from the sun, that is concentrated at the receiver, very small area receiver, that is accumulating the heat, and then from there the liquid fluid that is taking the this heat to the storage tank. From there, the heat in the form of steam or hot water that is taken for some type of useful work. Okay, so this was the diagram and how it works. So the entire area of mirrors and receiver move to track the sun. Here also we are tracking the sun every time. The reflector and receiver mounted on the top are moved to track the sun such that the reflector faces the sun at all time throughout the year. Something similar as we said so in the Fresnel type. So these systems have light structures and the efficiency that is also high. Now coming to the next type, that is parabolic trough concentrator. The parabolic trough concentrator, a trough made from shaped metal and coated with reflecting material such as highly polished metal. So that is usually aluminum or metallized plastic, which can withstand sunlight as well as rain and the elements. So we can see it in the diagram, schematic diagram for parabolic trough. So all of them, they are inclined. Okay, further, there is a tube in the center. There is a tube. So that is the absorber tube. From there, the fluid is being circulated, coming to the storage tank. So like 3. In case you're not getting, then there is a reflector, concave type, mirror type reflector, and there the blue colored tube. So 3 reflectors, they're connected through this tube, that is the absorber tube. Again, through that, the fluid, water or maybe other medium fluid for collecting the heat, that is flowing
circulating through the storage. Okay, so these surfaces reflect the incident sunlight onto a metallic collector pipe, that is a receiver that runs axially along the trough. These parabolic trough collectors can be connected in series on a common axis. Like these three, they are connected there in the series. Now the next one, linear Fresnel reflecting concentrator. So what is the difference here from the linear Fresnel reflecting concentrator and the previous one just we saw? Here in the diagram we can see there are many strips of reflector. Okay, so linear Fresnel reflecting concentrator is made up from multiple strips of straight reflecting material which are mounted on specially designed frames. So these mirrors are arranged in a Fresnelized manner which reflect the incident lights onto a local line of metallic collector pipe that runs actually above the array of reflectors. So the reflector strips are moved such that they are always reflect the incident sunlight onto the receiver tube. Okay, now coming to the diagram here, on the lower level base, on the ground level, we can see so many strips are there. Okay, these strips, they are reflecting through this, like on the base, then the sunlight is falling, it is reflecting back upside. So that is the absorber. Glass cover, then tubes are there, through that the fluid is, okay, the water or the fluid for collecting, that is circulated. Okay, so light that is falling first on the reflector on the ground, then to the reflected back to the surface of the absorber. Okay, absorber tubes, they are right there on the above level. So this is how it is working. Next one is heliostat field collectors. The heliostat field collectors, also known as power tower or central receiver plant. So how they are working? So the heat loss, okay, to minimize that and to minimize the cost in transporting a working fluid to a central location, because in previous type of collectors we have seen that the fluid collecting the heat that is flowing through the collector absorber. Okay, then it is coming to the storage tank. Now here, what is the difference? The use of sunlight itself is as a transfer medium. The sunlight itself is transferring. Okay, here in the diagram, the sunlight is falling on the heliostat, the small sized many. 1, 2, 3, 4, 5, and 2, 8. Eight heliostats are shown in this diagram, and they are inclined such that the sunlight falling on them, they are concentrating at the receiver. They're on the higher level on the top. From there, the receiver, there the heat is being generated. Now the fluid, our liquid may water, that is flowing through this receiver, it is circulating, and then that is collecting the heat to the thermal energy storage tank. So large distance circulation of the fluid that is avoided here. From the storage tank, the steam generator that is connected. Okay, so from there we are in this case like the turbine that is being operated, and we are generating the electricity. So in the typical central receiver, the reflector is composed of many smaller mirrors, each with its own heliostat to follow the sun. So many small mirrors are there, 8 in this case. They are there, and each one is having their own heliostat, and they're following the sun. And they are inclined in such a way that their light is concentrating at the receiver. So they are nearly flat mirrors that collect and concentrate the solar energy on a tower mounted receiver located 100 to 1000 meters distant. Okay, so such a large distance is there and sunlight is traveling. Okay, that's why the efficiency is increased. To maintain the sun's image on the solar receiver, heliostat track the sun throughout the day. Is mostly all of these type of collectors, they are tracking the sun so as to obtain maximum efficiency. So advantage of this heliostat field collectors. Okay, the solar energy is collected optically and transferred to a single receiver point, thus minimizing thermal energy transport requirements. Fluid is not being circulated here to large distance here. Sunlight that is being transferred. So they typically achieve concentration ratio of 100 to 1500 and so are highly efficient both in collecting energy and converting it into electricity. They can conveniently store thermal energy and they are quite large, generally more than 10 megawatt, a big value, and thus benefit from economies of scale. So these are the advantages which we are getting from this type of collectors. Okay, thank you.